Since the radicals have different indices, we cannot apply the product rule of radicals directly. Instead, what we need to do is rewrite the expression with rational exponents and then simplify. So x squared y, instead of taking that to the cube root, we're going to write that as all of that to the 1/3 power. And likewise for our x, instead of fourth root, I'm going to write that to the 1/4 power. Now I'm going to apply the power rule for exponents. So that means taking everything in that expression with the 1/3 power, applying a power rule means that we get to multiply exponents. So it would be y to the 1/3, x squared to the 1/3. And likewise with that x, it's taken to the 1/4 power. Okay, and now right here, 2 times 1/3, that would be x to the 2/3 times y to the 1/3, x to the 1/4. Okay, so I just applied the power rule for exponents. Next, I get to add exponents with like bases. So I've got x to the 2/3, x to the 1/4, so I get to add exponents with like bases. So I'll have x to the 2/3 plus 1/4 and y to the 1/3. Okay, and now we need to get common denominators. So let's see, if I multiply 1/4 by 3/3, and if I multiply 2/3 by 4/4, then I could use a common denominator there of 12ths. And I would have 8/12 plus 3/12, so that would be 11/12 times y to the 1/3. The next thing we need to do is write each exponent with the same denominator. And the reason we want to do that is so that we can, at the end, write this in radical notation. So we've got the same indices. So if I do this in 12ths, I need to multiply that y to the 1/3. That 1/3 is going to get multiplied by 4/4. So I've got x to the 11/12 and y to the 4. All right, and now I can, both of those are in 12ths. So if I had x to the 11th, y to the 4th, and that was all to the 1/12 power, that would be equivalent. And then that allows me, I factor out that 12th, and then I can write 1/12 as a 12th root, and it would be x to the 11th, y to the 4th. And that's my answer. Okay, so let's see what we did here. We needed, if this really only happens if we have different indices, then we cannot apply the product property of radicals. Okay, so instead we'll rewrite with rational exponents. Then we apply the power rule, add exponents with like bases, and then at the end we want to get the same denominator so that we can factor out that fractional denominator and then rewrite in radical form.